We are looking at section 5.6, the last section of chapter 5. Some things we're going to be looking at we have looked at before about this exterior angle theorem. Before we said that this angle would be equal to the sum of the interior angles. So angle 1 would be equal to angle 2 plus angle 3. And so this is just stating the obvious here that angle 1 is greater than angle 2, and angle 1 is also greater than angle 3 individually. And then we're going to look into this next thing that you'll need for your entire academic career is to realize how an angle is related to its opposite side. So if we look at this angle y, its opposite side is x to z. And so if we were to compare angles and say that this angle y and this angle z, if y is greater than that, then we can also say this about the sides. Then the side opposite of angle y, the larger angle, that side must also be greater than the side that is opposite of z. And a good thing to notice is the angle letter is not included in this side. So xy in the triangle xyz, z is missing, therefore that's the angle that it's related to. And then the last thing we're going to look at is the triangle inequality theorem. And so this is simply stating that any two sides, their sum must be greater than the third side. So for example here, 3 plus 3 is 6, it is greater than 5. 5 plus 3 is greater than 3. And then over here we see a failed. 2 plus 2 is not greater than 6. And then looking in at our first problem here, we're just trying to pick what would be the longest side. In doing so, we can see that these are a linear pair, so they have to add to 180. So I know this angle here is 120. And as we have angle A here, the side is BC, which is going to be the longest one. Here, we're looking at the theorem. So if we add 3 plus 7, it is not greater than 12, so no, this will not work. So 3 plus 7 is not greater than 12, or it is less than 12. Here we're comparing some angles here. Here's restating that theorem, that angle 1 outside here is greater than both of these interior angles. That's all that's being said here. Going back into the past here, so we have alternate interior angles with 3 and 4. And then we know that when we have parallel lines, those alternate interior angles must be congruent or equal to each other. And so this last one is saying, well, if we know that m is greater than 3, and we know that 3 is equal to 4, then by substitution property, we can say that the measure of angle 1 is also greater than 4. So here we're just putting in order from smallest to largest. And so we're talking about angles, but we're given information about their side measure. So I could see that K, 5.6, and its side is the longest one. And I can see that L is the shortest one, and M is in the middle. Here you're given this, so you can draw a triangle if you want. Or you can just go, well, I can look at the sides. I'm looking from smallest to longest. So 2 is obviously smaller than 5 and 6. What letter is missing from BA? C is. So that's what angle we're talking about here. So you can approach it that way by just simply writing the missing letter, and that's the angle. Or you can draw it out. Here we're given two angles, so we can figure out the third by adding and subtracting from 180, get 47. And then we could see, we can go by angle measure. So 40 is the smallest one, so M here. So that means its side ON must be the shortest one, and so forth. 2 plus 6 is not greater than 13. 4 plus 9 is greater than 11. 9 plus 11 is greater than 4. And 4 plus 11 is greater than 9. So this is an example where it works. Here we're trying to pick out the third side, what it can or what it might be. So there's two things we do here. We're given 7 and 10, so we subtract them to get 3, the lowest part of that limit. And then we add those same numbers to get 17 to get the highest one of that limit. So, and then very similar for the last one. We add them to get 18 and subtract to get 6. So it has to be longer than 6 and shorter than 18.